Welcome to Factoring Polynomials. Let's get started. So in this video, I want you to be able to factor polynomials. Alright, so polynomials, they can include quadratics, we got cubics, we have some of this craziness here, but the way we factor them, so a lot of it is not new. So the first thing that I would always check is if we have a greatest common factor. Can I pull something out of each term? So every time you see a polynomial, I would check that first. In this case, I can take a 2, because these numbers are all divisible by 2. I can take an x, because they all have an x, and I can take a y, because they all have a y. So I will pull that out, 2xy, just dividing all the terms by 2xy. What I'm left with is 3xy, because remember, if you go back and distribute this, you should end up with this here. And then taking a 2xy out of here leaves me with just a y. And then taking a 2xy out of here leaves me with 3x squared. Okay, if you need to check once you've taken out a greatest common factor, just go back and distribute and make sure you get back to the original polynomial. If you could continue to factor this, then you would. In this case, we can't, so we'd be done factoring. The next kind of polynomial you could factor would be if you found a difference of squares. Now we did this in quadratics. You have 16x squared minus 169. It's missing that b term. So that means if you notice it right away, you could factor it any other way. But if you notice that you're missing that b term right away and you're minusing, it's a difference, so you're subtracting, then you can take the square root of this first one, which 16x squared, square root of that is 4x. And that's the front term. And then we could take the square root of 169, which is 13. And then we have 1 plus and 1 minus. So this would be factoring it completely. Now, two new things would be factoring these cubics. Again, just like with the difference of squares, if you notice that you have a sum of two cubes, which means you can take the cubed root of both of these, you're adding them, and there's no other terms in the middle. Okay, then you can factor it a little easier with the certain template that we have here. So you'd have to identify what your A and your B is, which I'll go with that in just a second. And you would factor it into A plus B times A squared minus AB plus B squared. Now, you'll really need to remember this. Okay, it'll be given to you on the test, but you need to know how to use it. So if you notice that you have a sum of two cubes, your A is the cubed root of the first term. So cubed root of x to the third is just x, or 1x. If there's a number here, you'd have to take the cubed root of that too. B would be the cubed root of the second term. So the cubed root of 8 is 2. Now that I have my A, which is 1x, and that my B is 2, I just go and plug them into this template right here. Okay, so again, I took the cubed root of the first term to get my A, the cubed root of the second term to get my B, and I'm just going to go plug them in. Okay, so A plus B would just be x plus 2. And then A squared is my 1x squared, which is x squared, minus A times B. So minus x times 2, minus 2x. And then plus b squared. So b squared is 4. This is new and it's going to take some practice, okay? But now we've factored it. If you could factor this more, you would. In this case, you can't. So we'd be completely factored right here. The difference of cubes is similar to the sum of cubes. It just has a little different signs, right? So if you notice, you can take the cubed root of the first term and the cubed root of the second term, and you're subtracting, then that's a difference of two cubes. So again, we're going to have to find our A and our B, and then we can plug it in to another template. But in this case, it would be A minus B times A squared plus AB plus B squared. So you'll notice that it's similar to the sum, but you just have different signs. Okay, this will be given to you on the test also, but you need to recognize this and know how to plug them in. So the cubed root of x cubed is 1x, and the cubed root of 125 is 5. So I'm going to go plug them in. So a minus b is x minus 5. A squared is x squared. A times b is 5x. And then b squared is 5 squared, which is 25. If I could factor this more, I would. This doesn't factor anymore, neither will this, so I'm done. So from here, I factored into this right here. Remember, you can always check them all. I could go back and multiply these polynomials, and I should get back to x cubed plus 8, and the same thing here. So you can always check them. Please make sure you understand the sum and the difference of cubes. Rewatch it as needed. Make sure you write these templates down in your notes so we can refer back to them throughout the rest of the unit. Okay, so some other things you could notice, which is if you have a quadratic and you notice it's a perfect square trinomial, that means that it'll factor to the exact same thing and you could write it twice. So in this case, factoring would be x plus 3 times x plus 3. Which means you could write it once with the square. That's what we did when we were completing the square in the quadratic unit. Okay, so this factors here. You can also just get a general trinomial, which means you have 3 terms, it's a quadratic, and you factor the way we've always factored before. So in this case, you'd have x plus 10 times x plus 2. Because again, this would FOIL back to the original. X squared, 2x and 10x is 12x, 10 times 2 is 20. Now grouping may be new. It's definitely new with the 4 terms, but if you have 4 terms, I would look into grouping first. After I've checked to see if I can take greatest common factor out of all of it, then I would try grouping. So grouping is taking the first 2 terms together and taking out the greatest common factor of just the 2 terms. So in this case, I could take out an x squared, because they both have at least 2 x's. So I would factor out an x squared. That leaves me with x minus 4. And you can check that you did that correctly because this would be x cubed and this would be minus 4x. Then I go look at the second 2 terms, or the last 2 terms, and I see what can I factor out of here. Well, I can divide them both by 3, so I can pull a 3 out. I can take a positive 3 out, and that leaves me with x minus 4. Now, if you grouped correctly, the numbers inside the parentheses should be exactly the same. In this case, they are. So now the next part to the factoring is to take what was outside what you factored out. So x squared plus 3, that's one of my factors. And then that's why these should both be the same, because that's your second factor. If they're not the same, then you didn't group it right. So this long polynomial, I factored it by grouping, and this is what I end up with. So if I were to FOIL this again, I'd get back to this original polynomial. Again, see, if you have 4 terms, I would try to see if you could group it first. Now substitution can get a little bit long, but if you have a bigger, like this is x to the 4th, but I don't have 4 terms, so I can't really group it. But I know it kind of looks, it's kind of like an x squared, a quadratic that I could factor. Well, then I could use substitution. So I would want to turn this into a quadratic. So I would say that I'm going to make, let's say u equal x squared. Okay, so I'm going to go substitute u anywhere that there's an x squared. So the easiest way to see that is that I'd have 13u, right? Nothing happened to the 36. Now x to the 4th is the same thing as x squared squared, right? Because 2 times 2 would give me the 4th. So now I can plug in this x squared, the u that I'm making it, and plug it in here. So I'd have u squared. So now I have a quadratic, right, with the squared and the one single term that I can factor easier the way I've learned before. So now I could just have a u. So I know that I would have u and u. Multiply to 36, but add to negative 13. That gives me minus 9 and minus 4, because that's negative 13. Multiplying is positive 36. So there, I factored that. So because we substituted, now we need to go back and put x squared back in anywhere that there's a u. So x squared minus 9 and x squared minus 4. So this polynomial, by using substitution, factors to here. Now, sometimes that's as far as it will go. In this case, you should notice a difference of squares here. I could factor this more. So I'd have x plus 3 and x minus 3 is what I get from x squared minus 9. And then from x squared minus 4, it would factor to x plus 2 and x minus 2. So if I completely factored x to the 4th minus 13x squared plus 36, it would give me these 4 terms. Okay, so again, we plugged in u for x squared, so that way we could end up with a nice quadratic that we know how to factor. Then plug x squared back in anywhere that there's a u, and then factor more if necessary. Now, factoring polynomials can be tricky, especially with the sum of the cubes and the difference of the cubes. The grouping is new, and then of course substitution is new. Okay, so if you need to go rewatch those examples, please do so at any time, and make sure you wrote exactly what you need to in your notes, so when you go back you understand how we did that example. And then of course don't forget your questions and your summary. All right, that's it. See you later.